they will talk about network-wide visibility in hybrid cloud environments. The agenda, very briefly, we're gonna touch base upon the hybrid cloud challenges for enterprises. We'll review the NetBeez agents offerings, what you can deploy on-prem or in the cloud to monitor performance between the two environments. We'll also provide some configuration examples on how you can be proactive in alerting and performance monitoring of hybrid cloud environments. And lastly, we're gonna put everything together in a very simple and short demo about proactively detect performance issues that are occurring between the two environments. So let's talk about briefly hybrid cloud environments. What does it mean to have a hybrid cloud? Hybrid cloud means when generally you have one or more public cloud, such as Azure, Amazon Web Services, or Google Cloud, for instance, just to name one of the most commonly used, and your own on-prem data center. So the extension of your enterprise managed network to public cloud environment makes basically, in a simple way, a hybrid cloud. In our example, of course, we have very simplified with the network diagram, where we have an on-prem data center and two public clouds, and then, of course, a wide area network. So the challenges, though, when extending your network to the cloud come in different ways. If there is a performance issue, perhaps workloads that are shared between on-prem resources and cloud resources. If you see, for example, there is a slowness in the transfer rate between either your private data center and one or more public clouds, or even between the two public clouds, if they're somewhat in communications, right? Where do you start your troubleshooting? The second challenge is that most of traditional network monitoring tools don't really extend to the cloud. Typically, you work with your own on-prem SNMP-based network monitoring solution that gives you device status in terms of your routers, switches, and other network hardware, your firewalls. But generally, on the cloud side, you tend to use more tools that are provided by the cloud provider itself. And sometimes also extending those tools to the cloud is not very straightforward or very simple. You have limitation also on your visibility, also because the cloud is somewhat abstract and you don't have a full visibility into the underlying network oftentimes. So really having the same type of visibility that you do for on-prem cloud environment most often is not possible. Third, a lack of end-to-end measurements. It really impairs the ability to proactively detect application issues. And this, as we'll see, is very important to be one step ahead of your users or customer in detecting and addressing network performance issues that then can trickle down to your application or services delivered. So NetBeez has in place a different type of agents to really understand gain visibility between the two environments. These agents will allow you to extend your distributed network monitoring to public clouds, allows you to detect loss of connectivity or performance degradation issues, and also isolate where the root cause might reside, and also notify you about performance degradation issues, as we'll see. For on-prem, most of you should be familiar with our hardware appliances, which can be wired or wireless. This is mostly used on WAN environments. And then we have virtual machines. We support Linux, and now with 11.1 also Windows servers. So technically, you can also use a Windows service as a network agent on your dashboard to deploy a NetBeez sensor on your on-prem cloud. Lastly, we also have integration with networking vendors such as Cisco and Extreme, and this is always based on KVM technologies or Docker hosting. For the cloud, we have different deployment options. We can deploy a NetBeez agent on the cloud via a software agent. We support Debian or Ubuntu, for instance. You can deploy a cloud instance. We have predefined AIMI for AWS, and for Google and Azure, we have a similar template. And then we also have a software container, which is also another opportunity to deploy NetBeez on the cloud, but also on-prem in some situations. So the nice thing is really that extending your monitoring beyond your premises is very easy, it's very simple and almost seamless from a monitoring perspective. So let's see what type of configuration are available to really detect proactively end-to-end performance issues. There are two sets of tests that you can configure in NetBeez, the targets and the scheduled tests. So the targets are those a way to monitor assets, application, or services through real-time tests. For example, a target may include ping, DNS, HTTP, tracer, or path analysis. So in the case for hybrid cloud monitoring, we would recommend to configure ping test between the two environments. And the ping test allows you to not only proactively detect connectivity issues between on-prem and cloud and vice versa, but also to measure packet loss and high latency, which are two major component that may impact also your throughput, your bandwidth to the cloud, thus your application or services. On top of the targets, you can achieve being proactive because you can attach to targets alert profiles. So we'll see an example of a watermark alert in the demo that will notify you if latency crosses a certain threshold or packet loss is above a certain threshold. And then there are the scheduled tests. In the case of hybrid cloud monitoring, iPerf via TCP or UDP are great ways to have consistent measurement between your on-prem and cloud and vice versa. And also with the iPerf, you can understand what is the average throughput that you can achieve between the different environments. And on top of iPerf, you can also generate performance reports. As you know, we have now reporting functionality also for scheduled tests, and actually in the future releases, you will see also the new report format, including for scheduled tests, including iPerf. So the benefit of such a deployment is, of course, to rely on NetBeez anomaly detection system to be proactive in detecting all those situations that might impact your hybrid cloud performance. The important thing is step one, really to detect and alert the issue, and we'll see how we can achieve that with for example, a watermark alert that tells you if the latency crosses a certain millisecond value, and then identify where the problem is occurring and notify the team. So we support, of course, email notification, but also integration via out-of-the-box integration with, for example, Slack, PagerDuty. And then step number 3 would be, of course, to troubleshoot or repair. And that's something that generally will be done by your team on the network itself or whatever environment that is showing the degradation issues. So by doing implementing such anomaly detection, really your team can be more proactive in managing hybrid cloud performance. Again, if you have a question, please feel free to share in the chat or keep it for the Q&A. Let's show now a quick demo. Again, I did a recording a few minutes before the start of this event, but I'll be happy also to review some part of the configuration live. But I just want to show you how this demo, what will involve. We have a demo dashboard with the 3 cloud agents representing 3 different clouds, in this case, Azure, Amazon AWS and Google Cloud. And we have two agents on our on-prem data center, a VM and a Docker. And then we have a set of hardware and other type of sensor for our wide area network, which at the moment is not relevant as we will focus on specific this portion. And the goal of the demo is really to show you how we can detect increase in latency between on-prem and cloud, and then how you can get alerted and what impact this increase in latencies will have to the applications that you host. So let me share the video of the demo, and you can see this demo dashboard that we have a certain number of cloud agents connected to it, as I showed you before in the slide, and we also see the data center and the virtual container. This is the cloud agent. All tests are green, meaning we have a good measurement from a ping perspective from the cloud, and same from the data center virtual agent. We have good measurement. We also created a hybrid cloud monitoring target to our 3 public cloud. We have good latency, no really packet loss. And this is a good status right now to have good performance between the two environments. To prove that, we run a NiPerf test based on TCP, originating from the data center virtual agent and testing the cloud Azure network. So we'll see how much bandwidth we can achieve. Keep in mind our lab has a very small kind of simple connectivity to the cloud, so we cannot reach really more than 90 megabits per second. So under good condition, we expect to, of course, kind of reach almost this 90 megabits per second. So the HyperF test now is running. Again, source on-prem, destination the cloud agent, and we see that overall we're kind of reaching that expected throughput, as we also have a good performance. So yeah, the average is 69.6 megabit per second, not bad. And now I want to show you a alert that I have configured, a watermark alert that will notify me if the 1 minute average latency of my test will cross the 200 milliseconds. And I applied these alert profiles to all the targets that are running on the data center, and also on the hybrid cloud monitoring target that includes ping tests to my 3 public clouds. And as you can see on the right-hand side, there was already an increase in round trip time, right? What happened basically is like we're simulating now a latency increase between my on-prem and the cloud environment, and you can see that the alert profile triggered this increase in latency and is generating on all the ping tests for that data center virtual agent alerts. These alerts, of course, this will be the proactiveness, the notification that your team can receive, letting them know that something is not right on-prem, and that might impact, of course, transfer to your cloud. So to prove that, now we're running also another HyperF TCP throughput test from the on-prem agent to the cloud, and we verify how much this increase in latency between the two environments is impacting your throughput to the cloud, and also your services that would go over this link, this connection. So as you can see, our round trip time increased almost by 200 milliseconds, so it's a noticeable increase. And as you can see, the actual overall throughput resulting is 6.31 megabits, almost basically 10% of the original throughput. So you can see how a very simple increase in round trip time or packet loss can have a high impact on your connections. So with this simple demo, we wanted to show you like a very clear use case on the benefit of being proactive in your hybrid cloud monitoring by using NetBeez and the built-in anomaly detection system. So I hope you enjoyed this demo, and I want to open time for questions. If you have any question about any of the content that you see